Hi there, science fans. Welcome to another episode of Science and Other Stuff for Senior Citizens. My name is Dan Casciano. If you like these COVID-19 videos, please subscribe to my channel and ring the bell to be informed of future videos. I've used the terms SARS-CoV and SARS-CoV-2 in several of my previous videos describing various aspects of COVID-19. So in today's video, I will be describing and contrasting SARS-CoV and SARS-CoV-2. This presentation is a response to a viewer's comment. The outline of the video is presented in this slide. I will be describing the similarities and differences of SARS-CoV and SARS-CoV-2, including the potential for antibody cross-reactivity. SARS-CoV and SARS-CoV-2 both belong to the coronavirus family. This large family of viruses can cause illnesses such as the common cold and severe acute respiratory syndrome, or SARS. Not all coronaviruses are dangerous, but some can be fatal. Both SARS-CoV and SARS-CoV-2 can be fatal. Coronaviruses can be spread from animals to humans. The CoV pandemic first passed from a certain strain of cats to humans, while the exact origin of CoV-2 has not yet been identified. SARS-CoV and CoV-2 are genetically similar. That is, their genome or instructional molecule is RNA and not DNA. As mentioned in a previous video, RNA and DNA are blueprints, or the instructional manual that dictates all of an organism's physical and mental traits. Many of these traits are associated with the body's proteins that are the product of those instructional manuals. In a human, these instructions are encoded in a DNA molecule and not an RNA molecule, and dictates a person's height, skin pigmentation, eye and hair color, physical and mental health status, and much, much more. The instructions in the SARS viral RNAs are responsible for the virus's traits, which include infectivity and immunogenicity. The immunogenicity of each of these viruses are generally associated with the spike proteins located on the surface of the virus. The spike proteins of SARS-CoV are not identical to the spike proteins on the surface of SARS-CoV-2, so it follows that their immunogenicities are not identical. Immunogenicity is the ability of a virus or foreign invader to cause an immune response in humans, such as induction and production of an antibody that can inactivate the virus or foreign invader. Since the SARS viruses are genetically similar, one would expect that the spike proteins of each of these viruses to be similar, but not identical, and consequently they would be expected to induce similar immunogenicity in the host or the human. This slide describes some of the traits of each of the viruses. The R0 or R0 values are almost identical. R0 indicates the average or expected number of people that can be infected by any one infectious person. If R0 is above 1, disease transmission can be expected to increase exponentially in the population and result in a pandemic. The incubation time and days between symptom onset are very different between the two viruses. SARS-CoV-2 infected patients seem to have milder cases and also don't require the same degree of intensive care when compared to patients infected with SARS-CoV-2. However, both virally infected patients have the same risk factors for severe illness. An extremely important question is whether there are enough similarities in the SARS-CoV and the SARS-CoV-2 informational blueprints to suggest that an antibody that inactivates CoV may also cross-react with and inactivate SARS-CoV-2. As it turns out, probably not. Even though the RNA sequence of SARS-CoV-2 share 80% sequence identity with SARS-CoV, it is not enough. When one considers that humans share approximately 98% sequence identity with the chimpanzee, 80% similarity is just too low. Also, there are apparent differences in the binding regions of the CoV and the CoV-2 spike proteins to suggest lack of antibody cross-reactivity. This is unfortunate because having been infected by SARS-CoV does not protect one from becoming infected with CoV-2. Some scientists hypothesize that there would be enough similarities, and those similarities could be responsible for the 40% SARS-CoV-2 infected humans that are asymptomatic. this hypothesis appears incorrect. Pfizer and Moderna vaccines expected to be granted emergency use by mid-December, and vaccination of healthcare and high-risk individuals soon thereafter. This slide describes recommended CDC guidelines to combat the spread of COVID-19 virus in the absence of a vaccine. Washing of hands, socially distancing, avoiding indoor and outdoor crowds, and properly wearing a mask will combat the virus in the absence of a vaccine. Recently, the CDC updated its findings on mask wearing, indicating that masks protect the wearer as well as those around you. Use of these proven methods will inhibit or slow down our country's trajectory into a viral abyss. For more information about science, visit my website at www.dcasciano.com. If you have any questions or would like me to develop a video on a specific science subject, leave them in the comment section below or email me at dan@dcasciano.com. Be sure to like this video and subscribe to my channel and ring the bell so you can be informed when I upload a new video. Thank you for watching Science and Other Stuff for Senior Citizens. Bye.